Welcome to Ask and Learn.
So to solve this problem, we're going to write a system of equations that both involve the length and the diameter, and then use that system of equations to solve for the length and the diameter. And so the first equation has to do with volume. So we know that the density is equal to mass over volume, and so volume is equal to mass over the density. And then we know that all the wire has to be used, and so our first equation is mass over the density, which is equal to the volume, is equal to the length times the area. So length times pi times d over 2 squared. And then the second equation has to do with the resistance. We know we want a resistance R, and resistance is equal to length times resistivity over the area. So again, pi times d over 2 squared is our area. So to figure out the length and the diameter, all we have to do is solve this system of equations for L and D. And so one way to do it would be to take the equation on the left and divide both sides by pi times d over 2 squared to get L by itself. So that gives us L is equal to m over the density times pi times 2 over d squared. And then we can take that value and plug it into the equation on the right. That allows us to solve for d then, using a bit of algebra. And then if we get a value for d, we can plug that into one of our original two equations and solve for the length. So whichever way you do it, we find the length is equal to square root mr over the resistivity times the density. And then the diameter, d, is equal to 2 over square root pi times m times the resistivity times the density times the resistance to the 1/4.